Okay, this will be the last video for this introduction to Lab 1. So in this case, we're using this transistor uh, to increase the current. So I guess I'll mention too that the work that you've done with op-amps so far, when you talk about a gain, um, we always talked about in 1001, it was usually talking about a gain with regard to the voltage. Here we're talking about, with this type of transistor, a gain with regard to the current. And if we look at this data sheet for this transistor, by the way, you can see you've got this flat part of the transistor, and then you have the emitter, the base, and the collector leads right here. So you want to make sure that you get this wired up properly. But let's see. All right, so here this is the current gain, and again, in the past we've talked about the voltage gain, which is just, say the output voltage divided by the input voltage for the op-amp. Now we're going to be talking about the difference between, the current going through the transistor from the collector to the emitter as opposed to the base current. So you'll again set this system up, and then you'll be able to gradually increase the frequency from the function generator until the relay is no longer closing. And this is, of course, an electromagnetic relay. Electromagnetic relays were first developed to actually use with telegraphs. So in other words, over some distance, you would you would have a decrease in power, and you would just use that power. Maybe you'd get to some switching station and to run a relay, and then you have actually a completely different circuit than would then pass on the signal. So you'd just be closing the relay at one point and then setting the signal on. But of course now we also have solid state relays which don't have any moving parts. But this is interesting because this actually has a clear case, and you'll actually be able to see this switch closing. So in this configuration, you can see that when the voltage goes high here, and this transistor switches on, and the coil activates here, and that actually pulls this just down to an open circuit. So the measurement right here is going to go to 0. When the coil isn't activated, then this is connected to the 5 volt right here, so then this should be reading high. So if we look at the relay itself, let's see. So you can see that on your breadboard you want it to straddle the two sides here, because as you can see, you're going to bring power into here. And the polarity doesn't make any difference. In other words, when this is energized, it turns into a electromagnet, and this is going to switch from this contact over to this contact. Doesn't matter what the polarity is. So you bring you activate your coil with these two right here, and it won't matter what the polarity is. And then for the power, right, here's your 5 volts. You want to bring that into the middle right here, so that can either switch between this would be when it's not activated, and then once the electromagnet is activated, the power is going to go over to here. So on your actual breadboard, these won't be connected to anything to match this circuit right here. Right, when that activates, this isn't connected to anything. The other side will be connected to the rest of the circuit. Okay, the other thing you'll notice is that you have a diode. This is not a light emitting diode here, and so the diode looks like this. And this gray side here, if you think about the arrow of a diode, then this would be the point. This would be the gray would be the point of the arrow. So I'll also just point out that there is information on the oscilloscope here. There's a playlist on using
the Tektronix oscilloscope, and also the function generator. You can click on that link, and there's a link to the manual and also a brief video on how to use the lab function generators.